All right, so it says the temperature in degrees Celsius of water in a pond is a differentiable function W of time t. The table at the right shows the water temperature as recorded every 3 days over a 15-period day. If you use the data in the table to approximate for W prime of 12, show the computations that would lead to your answer and indicate units of measure. So this came from the 2001 AP exam. This problem or part was worth 2 points. So if you have a table of values and you are trying to find the derivative, what do we use? Slope. Perfect. Okay, so what we're going to do is use slope to find W of prime of 12. So what you're going to do is look at the point to the right of 12 and the point to the left of 12, but not actually use 12. So we're going to use 15 and 9. So then you get -1/2, and then it says indicate units of measure. Even if you didn't know how to get to the -1/2, the units themselves were worth the point. So you just had to have a number with the units. The units in this case for the derivative are representative of the function over time. So degrees Celsius per day. So when we're asked to interpret the meaning of a derivative, such as in example 1, we're going to start to apply the concept of a nut, meaning you need a noun, a unit, and time. The noun in this case is the numerical value. So you can never be asked to indicate a unit of measure without having a number. So even if you don't know how to get the number, but you know the units, just throw any number in front of the units so that you get credit for the units. Does that make sense? Okay. So then in number 1, part B, it says interpret the meaning of the derivative from part A in the context of the problem. So what that means is take that -1/2 degrees Celsius per day and tell me what that means with respect to W prime of 12. So to interpret that or describe its meaning, what that means is that the temperature of the water in the pond, the negative tells me that the temperature of the water in the pond is what? Good. So the negative becomes decreasing. Temperature of the water in the pond is decreasing 1/2 degrees Celsius per day. And then this is the important part. We found W prime of 12. So that -1/2 degrees Celsius per day is only with respect to the 12th day. We don't know if this function is linear, therefore we don't know if the derivative is going to be the same at every point. So the temperature of the water in the pond is decreasing 1/2 degrees Celsius per day. Do not put a negative on the 1/2 if you use the word decreasing. The word decreasing implies the negative at the 12th day or on the 12th day. Okay? Okay, you guys expressed a concern with being able to use or interpret things on the calculator. So I included a couple AP calculator questions as part of our back to whatever review before we move forward and on into the second half of the chapter. So if you want to take out your calculator, we're going to look at number 2. It says, on certain work days, the rate in tons per hour at an unprocessed gravel facility arrives at a gravel processing plant is modeled by the function given, where t is measured in hours, and our interval is 0 to 8. So not only do we have a function, we have a closed interval. So a closed interval is super important if our FRQ is asking more questions, because that could mean that you have an extreme value. You could have an absolute max, absolute min. It means that you could have IVT or MVT. So that closed interval is super important. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. That is an initial condition. This right here, at the beginning of the workday, the plant having 500 tons of unprocessed gravel, that's an initial condition. During the hours of operation, the plant processed gravel at a constant rate of 100 tons per hour. A constant rate is like our derivative, so it's processing the gravel at a constant rate. Find G prime of 5 using correct units and interpret the answer in the context of the problem. So to find the derivative at 5, all we're going to do is hit math 8. So we're going to interpret the derivative. Turn off the light back here. So we're finding the derivative with respect to variable x. So it's d dx. We type our function into the parentheses. So 90 plus 45 cosine x squared divided by 18. And then where are we trying to find the derivative at? We're finding it at 5. So x equals 5. Before I hit enter, I'm just going to hit mode and make sure that I am in radian mode. Remember, in calculus, you are always in radian. Go back to my problem and hit enter. So what we see is that G prime of 5 is approximately negative 24.5875. And then it says, using correct units, interpret your answer in the context of the problem. So again, G of t, where t is measured in hours, and G is measured in processed gravel, which is tons, means that my units are tons per hour So this is kind of like the acceleration. What? Because it says on a certain workday, the rate in tons per hour is modeled by. So this was the rate. So this was like velocity, meaning this was like acceleration. This was one of the most missed questions because everybody put tons per hour and forgot the second square to the problem. So being a negative, what does that tell me about the gravel? Yeah, it's decreasing, right? Like it's slowing down. So the rate at which the gravel is arriving at the plant is decreasing by 24.587 tons per hour at t equals 5 hours. So let's write that out. So in order to use speeding up or slowing down, you have to also know g of 5. That's why there's something in my ceiling.
Margaret Russo and Isabella Jenkins. Thank you.
That this is, if you go to the original problem, it says on a certain day, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by G of T. So that what that means is G of T represents the rate in tons per hour. So G of T is kind of like my velocity, which means the derivative of it is kind of like acceleration. So that's why the derivative is tons per hour. What? So the only way you can use speeding up and slowing down is if you also know the velocity at 5. Because you have to know if it's positive. Yep. So that's why we're just going to say that it's decreasing. Yes. Correct. Majority of the time we talked speeding up and slowing down. Okay, so the rate at which the gravel is arriving is decreasing by 24.5875 tons per hour at t equals 5 hours. We'll probably see this question again when we get to related rates, which is 4.6. This is just a small snippet of the question. So the wind chill is the temperature in degrees Fahrenheit a human feels based on the air temperature in degrees Fahrenheit and the wind velocity in miles per hour. If the air temperature is 32 degrees Fahrenheit and the wind chill is given by W of V, and is valid from 5 to 60. Find W prime of 20. So again, if we're just looking for W prime of 20, all we're going to do is take out our handy dandy calculator, go to Math 8, and find our derivative of our function. At our point. This one, so the original wind chill is in miles per hour. So yes, our derivative would be miles per hour per hour. So W prime of 20 would be negative 0.2855. I always go with 4 just because it's easier. So again, the wind chill is given by W of V. So the wind chill is the temperature in degrees Fahrenheit a human feels. So you know how you want to make it per hour per hour? You're good. I was trying to interpret it. Just make sure you also have your degrees Fahrenheit. Because I feel like they snuck that one in there. Because it says the wind chill and temperature in degrees Fahrenheit. And I'm trying to go back to think about the explanation whenever we were AP reading them. And I feel like this is the one a lot of kids forgot the degrees Fahrenheit. Miles per hour. Per hour. Because the V is miles per hour. So like this 20, like we're here, it's hours. The 20 represents miles per hour. So when you're explaining it, it's the wind chill you feel is a negative 2.85 degrees Fahrenheit miles per hour at 20 miles per hour. That's sneaky. So this is a lot like what I had you focusing on yesterday, being able to interpret position, velocity, acceleration, and understanding kind of its connection to what we're looking at now. So a particle moves along the x-axis with the given position. Find its velocity. So velocity is derivative. So that's just 2t minus 4. Find its acceleration, which is 2. And then complete the chart for the first 5 seconds and show where the particle is on the number line. So S of 0 would be 2. So its starting position or initial position is 2. The velocity at 0 would be negative 4. The absolute value of velocity is 4. And acceleration is 2. At 1, you'd have 1 minus 4 plus 2. So 1 minus 4 would be negative 3. Negative 3 plus 2 is negative 1. Velocity would be negative 2. Absolute value is 2. And acceleration is always 2. So you can kind of just fill that in if you want. At 2 seconds, the position is 2 squared, which is 4. 4 plus 2 is 6. 6 minus 8 is negative 2. At 2, our velocity is 0. So what that means at 2 is that the particle is changing direction. So right here, because the velocity is 0, I know that the particle is at rest. At 3, 3 squared is 9. 9 plus 2 is 11. 11 minus 12 is negative 1. 2 times 3 is 6. 6 minus 4 is 2. 4 squared, 16. 16 plus 2 is 18. 18 minus 16 is 2. 2 times 4 is 8. 8 minus 4 is 4. So you can see sort of the quadratic aspect of this problem. And then 5 squared is 25. 25 plus 2 is 27. 27 minus 20 is 7. And 5 times 2 is 10. 10 minus 4 is 6. So Des, you asked a lot about like speeding up, slowing down. We could look at the speeding up and slowing down here. So because velocity is negative and acceleration is positive, the object is slowing down from 0 to 2. It's speeding up from 2 to 5 because the signs are the same. And then we can also talk about moving left or right. So since the position is positive but the velocity is negative, that tells me the particle, go ahead. Yep. So it's moving left and slowing down. Velocity is negative, acceleration is positive, so it's the same thing. And then here, velocity is positive, acceleration is positive. So, go ahead. Yep. Perfect. If the velocity is positive or negative. Nope. And that description would go down for the rest of them. And then on the number line, we're just kind of plotting our points. So at 0, it's at 2 units to the right. What, honey? Yeah. Yeah, what you're going to do. You're welcome. And then at that point, it moves left. So it goes to -1. Then it moves left more. Oh my gosh, I marked +1. -1, -2. Then it moves forward or to the right to -1. Then to the right to +2. And then to the right to +7. And then again, you can see here what direction is the particle moving, when is it stopped, and when is it speeding up or slowing down. We answered kind of all of those in our table, because slowing down, opposites, opposites, speeding up, when is it at rest. The number line represents the position of the particle. So like its initial position was at 0, 2. Then its position was at -1. Then its position was at -2. This shows its movement to the left. And then here at -2, it stops, changes direction, and then starts to move right. So this -2 represents where it changes direction. So at t equals -2, the particle stops and changes direction. So it'd be like kind of putting your car in reverse first drive. Okay, so then we have our speeding up and slowing down, and now we're going to talk about the word constant speed or stopped. So if velocity is positive and my acceleration is positive, my function is what? Good. If velocity is positive and acceleration is negative, then it is and if velocity is positive but acceleration is 0, perfect. Now, opposites, velocity negative, acceleration positive. Velocity negative, acceleration negative. And velocity negative, acceleration 0. Yes. Because it doesn't matter what the acceleration is. Yep, there's no speed. Because the particle is at rest. I'm sorry. I know it's a lot of physics recap for you too. Oh no. Okay, the graph below models the velocity of a bug on the interval from 0 to 13. Find the velocity at 3 and 11. So if the graph represents velocity, v of 3 and v of 11 would just be the what? Yeah, they're just the points. So here's 3. Good. And 11. It did not indicate units of measure, did it? Yeah. Well, what do we want to make it? Okay. All right. Acceleration. Perfect. So A of 1 means what is the slope at 1? Good. What is the slope at 5? Good. And at 9? Yeah. And if we stick with our units, exactly, it's meters per second squared. At what time does the bug turn around? Remember, the graph you are given is velocity. It'd be at 9. Exactly. So it all has to do with the fact that when does the bug change direction? It changes direction when the particle is stopped. Correct. So this goes back to that whole idea of, yep, it goes back to the sign chart. And does it change signs at the 0? And if it does, it changes direction. Exactly. So it says, at what time does the bug turn around? at t equals 9 seconds, the bug, and then give a reason for your answer. You can even make it simpler than that. At t equals 9 seconds, the bug turns around because the velocity changes from positive to negative. All you have to do is talk about the fact that it changed signs. I think D is probably the trickiest. At what? It is 7 to 10, so why is it 7 to 10? Yes. Yes. And yes. So in the interval 7 to 10, the bug has a negative acceleration because the velocity is decreasing. And you could say, therefore, a prime of t is less than 0. Okay, so I have some practice problems for you to do for homework.